Hey guys, welcome back. We are going to do notes for section 10.3 and 10.5 today. We were already on chapter 10 before our spring break. We had done sections 10.1, 10.2, and 10.4. So the whole chapter is about area. Today we're going to learn how to find the area of regular polygons. Okay, so that could be an equilateral triangle, a square, a regular hexagon, a regular pentagon, and so on. Okay, so in this picture we have hexagon ABCDEF, and it is a regular hexagon. And when we say regular, we mean all of the sides are the same length, and all of these angles would have the same measure. Okay, hexagon ABCDEF is inscribed in circle G. A polygon is inscribed in a circle if all of its vertices lie on the circle. Okay, so the hexagon, each one of its vertices is on the circle, so we say the hexagon is inscribed in the circle. GA starts at the center of the circle, goes out to the edge of the circle, so GA is a radius. Same with GF. So GA and GF are radii from the center of the circle to two vertices of the hexagon. Okay, so not only is it a radius of the circle, but we would also call it a radius of the hexagon. Okay, and then we have a new word, which is apothem. And an apothem is a segment drawn from the center of the hexagon, and then it goes perpendicular to the side of the hexagon. So in this case, our apothem is GH. Starts at the center and is perpendicular to the side of the polygon. Okay, and we're going to make one more note about an apothem. Not only is it perpendicular to the side, but it also bisects the side. Okay, so we are going to figure out a formula for finding the area of regular polygons. So we're going to start with this hexagon, and we're going to try to figure out a formula for the hexagon. So the area of the hexagon would be equal to the area of this triangle times 6, because I can fit this same triangle here, and I could fit that triangle here. I could fit 6 of these triangles inside the shape. So the area of the hexagon would be 6 times the area of triangle GAF. Okay, so let's think about how you would find the area of a triangle. The area of a triangle is always 1/2 the base of the triangle times the height of the triangle. Now, I want a formula that works for the hexagon. And this base of the triangle, I don't really want to refer to that as the base of the hexagon. Okay, we would not call that the base of the hexagon. Okay, we would just call this a side of the hexagon. Okay, so what we're going to do is, instead of using B for base of the triangle, we're going to use S for side of the hexagon. Okay? And then the height of the triangle is not the height of the hexagon. The height of the triangle is the apothem of the hexagon. So instead of height, we're going to say A for apothem. Okay? So S is for side, A is for apothem. Okay. Now we can kind of simplify this formula. If I take a side length and I multiply it by 6, what am I actually calculating? So if I take this side length and then I multiply it by the 6 sides, I have actually just calculated the perimeter. So instead of writing 6S, we're going to write P for perimeter. And then the 1/2, I'm going to put that out front, and the A I'm going to put right here. So the area of the hexagon is 1/2 the perimeter times the apothem. Now the question is, will this formula also work for a pentagon or an octagon? So if I were trying to find the area of an octagon, okay, I would still find the area of a triangle, but instead of multiplying it by 6, I would multiply it by 8, because in an octagon, I'd have 8 sides. So I'd be able to have one of these triangles on every side. So for an octagon, I would take the area of the triangle and multiply it by 8. Okay, so if I take my side length times 8, is that still perimeter of the octagon? Yes. Okay, so this formula doesn't only work for a hexagon, it actually works for any regular polygon. So let's fill that in at the bottom. If a regular polygon has an area that we're calling a perimeter we're calling P, and an apothem with a lowercase a, then the area of the regular polygon is 1/2 the perimeter times the apothem. So we're going to try to use that formula on the back side. So we have 3 different problems to do. Okay, the first one wants us to find the area of the regular pentagon, and it says that the perimeter is 40 centimeters. So the first thing I'm going to do is write down my formula. For any regular polygon, I can use this formula. And they have already given me the perimeter, so I'll go ahead and plug that in. Okay, what they have not given me is the apothem, and I'm going to need to figure that out. So let's go over here and let's draw in the apothem. So we're going to go to the center of the pentagon, and we're going to draw in our apothem. Remember, an apothem is perpendicular to the side length, and it also bisects the side. So if this perimeter is 40, I'm going to take 40 and divide it by the 5 sides. So each side will be 8 centimeters. And since the apothem bisects that, I get 4 centimeters right here. Okay? Now, I'm going to create a right triangle because I know how to solve right triangles. That was chapter 8, solving right triangles. Okay? I can figure out the other, I can figure out the apothem if I know this side and maybe one of the angles. So neither of the angles is given to us, but I can figure one of them out. So what I'm going to do is I'm going to imagine there's a circle here. And there are 360 degrees in a circle. Okay? But that circle is going to be divided evenly among all of the right triangles that I could fit inside this shape. Notice I can fit 2 right triangles on this side. So I'd be able to fit 2 right triangles on this side, and this side, and this side, and this side. So I'm going to take 360 degrees, and I'm going to divide it by 10. So this angle right here is going to be 360 divided into 10 triangles. Okay? So that tells me that my angle is 36 degrees. Okay? Basically taking this circle and I'm dividing it into 10 pieces of pie. Okay? 10 triangles. All right, so to solve this triangle then, I'm going to need to use trigonometry. This is not a 30, 60, 90 triangle. This is not a 45, 45, 90 triangle. Okay, I can't use the Pythagorean theorem either because I only know one side. So I'm going to have to use trig. From the angle that I know the opposite side, and I'm looking for the adjacent side. I don't really care about the hypotenuse. So I'm going to write SOHCAHTOA up here at the top. Remember, that's just a way of remembering that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So again, we said from the angle, we know the opposite side, and we're looking for the adjacent side. So we're going to use tangent. So over here to the side, I'm going to write down tangent 36 equals opposite over adjacent. And then I'm going to get a by itself. So I am going to multiply by a, divide by tangent 36, divide by tangent 36. Okay, this is gone, and I get a equals This is gone, so I have 4 over tangent 36. Okay, that is your apothem, and we can plug that in for the apothem. And that would be centimeters. Okay, so my exact answer then, I'm going to take 0.5 times 40 times 4, and I get 80. So multiplying these three things together gives me 80, and my denominator still has a tangent 36 in it. And then centimeters times centimeters is centimeters squared. Okay, remember area always has some unit squared. Okay, that is my exact answer because I haven't rounded anything. But I want to know, what is that approximately? So I'm going to take my 80 and I'm going to divide by tangent 36. And I get approximately 110.1 centimeters squared. So that is your approximate answer. Okay, let's do another one. So again, I'm trying to find the area of a regular polygon, a hexagon this time. So here's my formula. Okay. The apothem length is 12. And I have to find the perimeter, okay? So right now I'm going to leave the perimeter blank because I don't know what it is. And I'm going to fill in the apothem. Okay, so just like we did the last time, we're going to make a right triangle. And we're going to figure out what this angle is. It's going to be 360 divided by 12 this time. And the reason we're dividing by 12 this time is because I can fit 12 of these right triangles around the shape, okay? So 2 here, 4, 6, 8, 10, 12. So we're going to take this 360 degrees and divide it among those 12 triangles. Okay, and we get 30 degrees. So this is a 30, 60, 90 triangle. And I know in a 30, 60, 90 triangle, this is my n square root 3. 12 is my n square root 3. That means my n must be 4 square root 3. And then this side must be 8 square root 3. So n, 2n. This is n square root 3. This is 4 square root 3 square root 3, which is 12. Okay? If this is 4 square root 3, then the entire side is 8 square root 3. And then I can take that side length and multiply it by 6. And I find out that my perimeter is 48 square root 3. Okay? So we're going to do 0.5 times 48 times 12. And we get 288 square root 3 inches squared. That's your exact answer, and that is approximately, I swear my husband is trying to make noise. Okay, so 498.8. I don't know if you guys can hear all that background noise he's making, but okay. He's blowing his nose, changing over the laundry, all kinds of stuff. Alrighty, so exact answer, approximate answer, and then we have one more to do. All right, so the last one, we have a triangle. Now, for any triangle, you can do 1/2 base times height. But if the triangle is regular, then you have another option as well. You can do 1/2 PA. Now, I'm going to show you both ways because a lot of people make mistakes with the 1/2 base times height. So I'm going to show you how to do it both ways, and then you can pick which way you want to do it. All right, so it says that the side length is 12.5 inches. Okay, that means the perimeter would be 12.5 times 3, so 37.5 inches. Okay, we need to figure out the apothem, so I'm going to draw it in. Okay, I'm going to make a right triangle. if this entire side is 12.5, then this side right here is 6.25. Okay? And this angle is 360 divided by 6, because I can fit 6 of these right triangles inside the big triangle. 2 on this side, 2 on this side, 2 on this side. So I get 60 degrees. So that means this is a 30, 60, 90 triangle. Across from the 60, that is our n square root 3. N square root 3. So our n would be 6.25 radical 3 over 3. 6.25 radical 3 over 3. Okay? If you take that n and you multiply it by the square root of 3, you'll get 6.25. Okay, so let's plug that in for the apothem. Okay, and then we're going to take the calculator, and we're going to do 0.5 times 37.5 times 6.25. I'm going to hit enter, and I'm going to see if I can divide that by 3 and still see all the numbers. So let's divide that by 3. And I can still see all of the numbers. It's 39.0625. So I did this, times this, times this, and then I divided by 3. Here's what I get. I need to put a square root 3 next to it. Inches times inches is inches squared. So that is our exact answer, and that is approximately 67.7. Okay, now I'm going to do this problem again. We already know what the answer is. We're going to get the same answer, but this time we're going to do area equals 1/2 base times height. Okay, so our base was 12.5. Okay, what is the height? Now here's the issue. A lot of people, when they go to find the height of the triangle, they think they just take the apothem and double it. But you don't do that, because this dotted line here is not an apothem. Okay? It's not an apothem. So this dotted line does not have the same length as this solid line right here. So what is this length? Well, this is a radius. So it's going to have the same length as this radius. Okay? So think about this. Here's your n. This side is supposed to be 2 times that. So this would be 12.5 radical 3 over 3, which would mean this dotted line is also 12.5 radical 3 over 3. Okay, and if you add these two together, we get 18.75 radical 3 over 3. And that's inches. Okay, guys, I want to show you one other way of doing that. Okay, so stick with me here. This triangle here is a 30, 60, 90 triangle. Here's the 90. I know this big angle is 60 because the triangle's equilateral. So in a 30, 60, 90 triangle, this is your n. This is your n square root 3. So this is 6.25 radical 3. That's the same thing we have here. Let's write it that way. 6.25 radical 3. Okay? 18.75 divided by 3, that's where we got the 6.25. All right, now we're going to put this in our calculator. So 0.5 times 12.5 times 6.25. And we get the 39.0625, and then we put the radical 3 next to it. Okay, and again, that'll be approximately 67.7. So this is method 1, and this is method 2. I don't care which way you do it, both ways work. We get the same answer either way. Okay, so you can check Canvas for your assignment. Thanks, guys.